Magically, I seem to have just lost my speaker notes. Oh, I do apologise. We can essentially commence on this track, though. So, I'll be speaking about avoiding release paralysis, ironically, and the nature of how big enterprise software projects have failed, why they failed. Let's get online, shall we? Do you know what? Let's just restart the machine. Why they failed and what can be learned from them. Generally, Linux is solid. But not on this occasion.
Conference Wi-Fi, not so much so.
Yes, exactly. Fortunately, I can begin to present from my phone. Excuse me, I'm so sorry. Yes, so I'm Andy. I've done plenty of time as a developer, as a tester. I've done lots of operations work and everything from shipping complex distributed systems down to relatively simple cross-browser CSS testing. So, what is the big scary problem that we're concerned with? Release paralysis, fear of the unknown, the inability to ship software. We don't trust our tools and processes, and when we do attempt to make a change for the better, everything goes up in flames or sublimates like 10,000 tons of TNT. 1 second. I have empathy, I hope you do with me, for these problems, because I've seen them again and again. Okay, let me see if the Wi-Fi is willing to work. Can someone remind me?
Have you gone BWF? Yeah.
Right, so BWF. Okay, let's just tether. That seems to be fine. Okie dokie. Yeah, so I have empathy with failures of this type. You'll be pleased to know that is only my screensaver. This looks suspiciously like maybe it'll work. Yes, so there's some great gifts in here. That's the problem. This is preparing for deploy. This is actually attempting to deploy. That is the deployment itself. And this is the empathy that I have. Right, so right, so yes, and I feel your pain. Developers shouldn't be left having to try attempt these sort of tricks. It's no way to live. We deserve our 9 to 5, doing just what's required to ship quality code and then have our weekends carefree. Your choice of drink may vary. Right, so spoiler alert. This is the content of the talk. Docker has brought large-scale deployment processes down so anybody can use them, any team of any size, from one-man band upwards. Configuration management is no longer necessary to orchestrate a large number of servers. QA teams are an organizational anti-pattern, and I'll expound on that later. Automation of everything is key. Be more DevOps. Everyone's got to learn why their code is doing certain things in different environments, what those environments mean, and finally, release early, release often. And I hope some of you recognize parts of these from stagnated or difficult projects you've worked on, because removing these blockers is the shortest path to enlightenment. We absolutely want to feed off the generosity of the ecosystem. We can get a lot of things for free because the enterprise has open sourced so much. And I'll assume for the purposes of this talk that you're either in stealth mode or a business with some special sauce and subsequently I'll be recommending tooling of the free and private variety. So, otherwise naturally you'd be using the open source tools that are available. So, free tooling for private use. I have no affiliations with any of these products apart from plenty of alpha and beta testing, and the only thing that will cost you money is your compute power. Unfortunately, there's still no decent, understandably, free computing power. The Amazon free tier gives you a burstable micro instance which doesn't have sufficient power to really do any of these processes that we're talking about. So, release early or die trying. It's not quite as easy as it sounds, or maybe it doesn't sound easy at all, but everything is testable, from a monolith through to a mobile application or Electron on the desktop. You can still bring up WebDriver and test that code. You should be testing at the lowest level possible, and also the acceptance tests of the system as a whole. The question is, how much pain are you willing to tolerate to test something? So, brief description of the continuous practices. Continuous integration is everyone pulling together in the same direction, working on the same project, on the same main line of code, which means these aren't pull requests, these aren't branches, it's one team, one line. Continuous delivery is equivalent to your favorite furniture provider designing an item of furniture, cutting it into pieces, flat packing it, and delivering it to your door. It's everything required to put into production, except for the deployment. Making it useful is often the tricky part. But deployment should be done automatically. The machines are in control, and user acceptance testing is performed by real users, either on a subset of the functionality, as defined by feature toggles, or on the whole system, moving quickly enough to squash bugs as they occur in production. Relatively terrifying for many organizations. So, the 3 C's: integration, committing to a mainline, all tests run on every commit; delivery, putting all the pieces together and ensuring that they do what they are specified to do upon build; and deployment, taking that, putting it into production, ensuring its veracity in the same way as you would have done with a deployment, but in a full production environment. And during this whole process, people are the friction. Reducing their input is key. So none of these, all of these techniques have their own benefits, and not all of them are suitable for each organization. An air-gapped industry, such as defense or healthcare or finance, probably requires the equivalent of a Faraday cage with maybe a thumbprint scanner or some RSA cryptography in there to ensure that you don't leak the things that you don't want to leak. But assuming that we're developing web-based technologies, a lot of these are easy to implement. There's no dogma here, and the general mantra is reduce the friction between your laptop and your production systems. So different teams have different needs. We want to avoid having code that we can ship or that we want to ship, but we are either organizationally or procedurally unable to ship. Getting build times down is paramount. So, continuous best practices, relatively self-evident. I'm sure that everybody does a subset or a majority of these in their daily developer life. The most contentious, perhaps for me, is committing to mainline, but the benefits of that will become more apparent. Merging and rebasing really sucks. I don't know if anyone's had the displeasure of attempting to merge back a line of code which may have been worked on for days, weeks, or even months in isolation by a single developer who perhaps fell foul of the bus factor or similar. Reintegration can sometimes be harder than the writing of the code itself. Now, this model is really put in the front and center by GitHub, and the most difficult thing to remember here is GitHub is designed for foreign contributors from outside of your team to bring code to you and to have it reviewed upon merge. This is not the fastest way to get your code to production. It ensures some quality, but it's possible to get that quality without forcing this barrier between parts of the team. Teams with good communication can skirt these problems, and as the mythical Man Month has taught us, Communication pathways become exponentially greater with added teams, and Brooks' law dictates that you can't just throw people at a problem. So before scaling your team out, optimizing the processes that the existing team members use will decrease your time to production, ultimately the cost of software, and increase the quality. So this again is the GitHub model. Definitely not continuous integration. It looks complicated, and it can be complicated. Anybody who really says they understand Git, I may call a liar, not to their face. If you trust your team, show it. While this is good for open source, reviewing code from, as I say, unknown contributors, and reviewing everything where time is immaterial, for a team, this inherently shows a lack of trust between team members. Instead of enforcing this code review after the code has been written, why not pair with that person or that new team member? Bring them up to speed in the organization via experience rather than criticism, as good as that criticism may be. So we can compromise slightly where a developer is new or perhaps working on in a language or a feature that they don't understand. But I would still posit that it is an inferior solution to sitting side by side with somebody, sharing the keyboard, discussing each change, the name of each variable. It makes far more difference. And you may ask, who cares about this? Well, ultimately, the people who pay for this software, they're the ones who care because they want quick, fast, and easy, as unlikely as that may be. So if you trust your team, show it. And next, we get to testing. These are many people's favorite pyramids. People travel from the world round to see them. This is my favorite pyramid. By pushing tests down to the lowest level practical or possible for that feature, one maintains a prompt test suite, something that can run on every commit, something that with a file system notification plugin or tool of some description, you can have run every few lines of code that you write. This speed of iteration, all the way from your laptop to production, as difficult as test-driven development may be for some people, will ultimately increase the quality of your code and reduce the cost. So the unit tests are relatively easy. Integration and system tests, how do we reduce the friction there? Docker Compose is a magical new tool, and when I say the enterprise is exposing their tool set for the common developer, this is an example of Google contributing C group patches into the kernel as much as 9 years ago, and people gradually realizing and then building useful developer-friendly tooling around that. So Docker Compose will allow you, as I'm sure many of you are aware, to declaratively define your application and its dependencies and its configuration and its networking and its data stores. That means that by using a few extra techniques, which I'll get to, you can test a production-like system on your local machine. And testing is absolutely imperative. All code must be testable. You should never have a QA team larger than a development team. And I would question having a QA team larger than 15 to 20% of the size. The behaviors that QAs expound are things that developers should already be doing. And a QA team, rather, is better placed with requirements analysis early on in the development cycle, with test case review, and treating the whole project as an ongoing quality procedure, rather than coming in halfway through a sprint, retrospectively looking at code after it's written, so maybe analogous to the pull request code review stage, and then pushing things back. This will only delay the release of software. The idea of very fast iteration is also to prevent developer context switching. If you've spent your mind share and your energy developing a piece of code, it doesn't come back to you for 3 or 4 days or even longer, you need to consciously re-identify your intentions. You need to go back and look at the test suite to make sure that you understand what it was that you were developing. Now, these things may not seem particularly egregious or slow, but they're much slower than the fast path. Getting the thing done earlier, correct requirements, correct test suites, ship it to production. So in terms of testing, I've left various notes here for posterity. These are my firm beliefs. but I won't go through them now because it's a little dry. There is plenty of resource available on the internet about unit testing, test-driven development, the best way to do these things. So where does the QA team add value? The destructive ways that they break your code should be part of the development process. They should be things, a mindset that you put yourself in. This concept of having developers not thinking of the edge cases is so ridiculous. If you don't understand your domain fully, you risk not shipping the correct solution for that software. And again, if something gets thrown back, or when it comes to the user acceptance testing or the business actually having a look at the thing, and you don't hit the right nails on the head, then you're taking more time again. And it's all about reducing the cost of software and the time to production. So, in terms of how continuous integration works, I mean, you'd think it was simple, but in fact, all the big players do things very slightly differently. Google has one monolithic repository, which, upon commit, identifies the other touch points, the other services that are touched or that have communicated with this software, and will spin up in its cloud instances a huge test suite and verify that your code does what it's supposed to do. Then that'll get into production. There's a code review step for Google. Facebook will curate things into production with weekly windows, as will Spotify's release train. GitHub and Stack Overflow take things one by one up with chat ops style integrations, and all these things are available online. But they all move more slowly than Amazon, which as early as 2010 was putting 11.6 seconds between each code release. And that was clarified in a Hacker News thread, whereby that's not the case that they have 1,000 servers and a single push to each one. That 10,000 servers is one atomic step for them. That's one deploy. So that's in the order of many, many thousands of releases a day. And they are, out of the lot of them, the only one for whom the e-commerce load time of a page really makes a difference. And I would suggest that that agility is all encapsulated in these continuous practices. So back to the list of practices: commit little and often, test everything, automation, optimization, and the radiation of information. Build, measure, learn, repeat. Make sure everyone can see what's happening in your pipelines, make sure everyone knows what's going on. And we are just ready for the first stage of simple continuous deployment. So again, these tooling recommendations are going to be free and private. All developers no doubt perform the first two actions on this list relatively often. Seems like second nature. But this does seem like a lot to add on to the bottom. And that, frankly, is because it is. In order to get to this level of development process as a single player or as a small team, one must become a generalizing specialist. And this is encapsulated in the buzzwordery of DevOps. Unfortunately, it's a necessity, and we all must really strive. So that's a cat of all trades for reference. And this is some inspirational scribblings. Anything can be learnt in 20 hours. That's 2 hours a weeknight for 2 weeks. You can really take these things on board. And this is, I think, a tremendous way of upskilling oneself. Dedicate to something and attempt to go there. There are plenty of people happy to mentor you in the community. And this sort of thing will, with a DevOps slant, really speed up your deployment times. So, DevOps movement finishes with the Terminator of continuous operations, which encapsulates all these processes. We've moved on from waterfall, even agile to some extent, and the mantra is continuous learning, continuous iteration. Importantly, show that you care and support your code in production. This is the difference between a developer and a DevOps, if you can take the singular of the thing. They will know what's happened, why it's happened, and be able to feed back to the developer. Again, why this communication cycle? Why not have full access to all your systems and allow your developers to go and correct their problems, identify missed deploys or failures to cover test cases sufficiently. So with that brief call to arms, What development environment is best for continuous deployment? Now, the barrier to entry for enterprise-grade deployments is pre-packaged application units. So this is what Google ships to its servers countless times daily, also known as namespaces and C groups, also known as containers, aka Docker. Docker is really a revelation, whereas before one would have to maintain virtual machines and maybe run multiple virtual machines on as many cores as you could fit into a development machine. Docker now allows you to run the same large systems on your laptop by reducing the virtualization overhead, moving it into software as opposed to hardware. So you can bring pain forward by developing inside a Docker container. Now, there were historically some issues with file system notifications in Docker for Mac. They have just been remedied, allegedly. So I invite you all to try installing Docker for Mac and seeing if this will again speed up your deployments. So the ideal of Docker is write once, run anywhere. Now, this isn't the case for anything, as history has proven. The important differences when running a Docker container locally versus on a production system is that Docker proxies through system calls to the kernel of your host machine. So you've got one difference there already. There are startup options that could change depending on containers, depending on your invocation parameters. You can restrict privileges, you can grant privileges. Networks can be configured differently, and often are, whereas the local links obviously don't scale cross-server in production. And never underestimate the hardware differences for exposing race conditions or latency-sensitive bugs. Other container runtimes are available. Rocket from CoreOS is quite wonderful, but is focused less on developer experience and more on platform building. So back we are to Docker Compose. The ability to spin up these environments should not be underestimated. It saves having to log on to a remote system. It allows you to use all your local tooling, and it reduces the time that it takes you to fix any of these bugs. But of course, you will need test data if you're going to have any sort of production-like experience. And to that end, running a nightly scrub job for test fixtures from your production database, dumping that somewhere without emails or passwords or anything that may be specific or personal information, and making that available to your developers means that when you do have that critical bug that's taken down production and is so difficult to replicate, you have your own test environment. You have your own full system running locally. I can't overstate that enough. Real data is very important because maintenance of test fixtures, is paramount. So, source control. You think this would be easy because everyone loves GitHub and they have released, well, just this morning, I think, permitted people to have unlimited private repositories, which, yes, it is a little bit more expensive, yes. But so this doesn't fit our criteria. It's not free. Oh, there we go, it's not free. So, criterion, it's not free. And despite useful or beautiful best-in-class UI and the social features, we're working on the principle that we have our own team close together. We don't need to communicate via side channels. We're doing this by one method, and that's communication ear to mouth, mouth to ear. As you wish. So the alternatives are really Bitbucket, which is a decent system. Everything is free. The UI is not comparable. Or my personal favorite and recommendation, GitLab. Now, for those of you that haven't used GitLab, they offer a hosted service similar to GitHub. It's not as beautiful by any means, but there are a few special extras. One is that they ship you a Docker container containing not only the application, also the databases and Redis that support it, single container, and you can host that wherever you like. So the speed of interacting with GitLab remotely on their GitLab.com installation is not particularly fast. It's a Rails app which obviously struggles to scale. However, spinning up the container in your own environment goes very, very quickly indeed and has a killer feature. It's got a built-in build server. which is quite unusual. There are so many new hosted build services, Travis, sort of breaking the ice for many more, CodeShip, Semaphore. There are plenty. And while Semaphore, out of the lot of them, has 100 builds for private use per month, you're still integrating remotely, and you're still using someone else's servers for that. So with GitLab, you're able to spin up your own worker containers and parallelize your test execution. And it's as simple, a la Travis, as dropping in a gitlab.yaml into your build. And that will get picked up and run automatically. And as you can see halfway down, or maybe 2/3, this actually duplicates itself remotely to Bitbucket. Yes, it is Bitbucket. Because once we're running this locally, then we need a backup strategy. And rather than think that we're optimizing something, but introduce a single point of failure, the thing goes off remotely, and it works very well indeed. I recommend that you try it out. Again, I have no affiliation with these companies. So provisioning. Provisioning was shaken up by Terraform a couple of years ago. It's a Go-based tool for deployment of cloud-agnostic infrastructure. You can deploy to multiple clouds, wire them together, configure load balancers, policies. It supports the major incumbents as well as bare metal. And if you want somewhere to deploy to, these guys, Scaleway and OVH, will both give you relatively cheap hosting. In terms of bang for the buck, OVH have done me very well. So deployment, freeze your dependencies, whatever you do. NPM shrink wrap has to be used. Most people don't tend to pin the versions of the packages that they install into their Docker containers. And this is slightly contentious. There's a question of whether you should trust maybe the package maintainers of Alpine, which is very much the operating or distribution of choice at the moment for Docker containers due to its very small size. There's a question of whether they should be trusted more than NPM authors. Your experience may dictate your behavior there. But ultimately, anything that's not shrink wrapped will come back and bite you at some point in your deployment's lifetime. So trust the process, deploy things continuously, and push to a Docker platform. Now, this may seem complicated. Certainly, the Kubernetes and Mesos platforms are vast, hulking code bases. However, Kubernetes in particular supports a number of platform as a service providers atop. And in addition to this, Google will now also host your Kubernetes master and allow you to just spin up semi-ephemeral worker nodes onto which you have access to the Kubernetes API, onto which you can deploy something such as Deis or Flynn. These give you the power of a distributed system without any of the legwork. And in the spirit of reducing friction, they also relieve you of a number of DevOps duties. So the UI allows huge control and seriously reduces your ops burden, which gives you more time to focus on things like logging. Your application should be emitting these logs. You can attach an rsyslog remote logger to Docker containers via syslog drivers and emit them to a Kibana instance. So the Elk stack is something else that you would have to run yourself. You need to have this sort of information for a post-mortem, either post-intrusion or sort of software failure. And again, this can be hosted in a free tier by these chaps. It's enough to fire your alerting from. It's enough to do a post-mortem as long as you're relatively prompt with it. And obviously, as soon as you start making money from your special source or business, it is worth paying for these sort of hosted services because you are delimited slightly. Monitoring, again, these guys are all free. You pay for a less frequent poll interval, but nevertheless, you still get your notifications. Datadog will give you monitoring across your infrastructure, and these guys will, Datadog gives you up to 5 servers for free. So with all this free information being spouted out, then you can fire off your own alerts with things like Zapier, which will ingest an alert from somewhere or an email or some sort of condition and fire you an SMS or a Telegram message or a Slack, or whatever it would be that you want. And these things are, again, imperative. You need to know when things go down unexpectedly because you're running on the edge. Quality and constant iteration are very much part of this cycle. If you don't want to use the free tier or you want something a bit faster, BIP.io is a Node application which performs the same functions. You pay the overhead of hosting it yourself, but you get something that's far more responsive. Okay, so that's a sort of basic continuous deployment pipeline. But of course, if we want to scale this out, or potentially avoid the downtime when we are deploying, which could be masked or obfuscated by status pages or load balance configurations, we can still do this better. So complex pipelines, we need different deployments, some sort of testing of those deployments, and catastrophe management. Continuous deployments. There's three main types of continuous deployments. One of them costs twice as much to run as the production stack. One of them is human-driven, and the other adds application complexity. And in case you hadn't guessed, the Canary release is the one with the additional complexity. But because you're inserting a single instance of a new service into your production infrastructure, then you don't have to pay for an entire duplicate of your infrastructure to test in. You have all your caches warm. You don't suffer thundering herds when you cross over or have to pre-warm. And obviously, the hit and hope style of deployment is not good for one's sanity. So post-deployment tests are important. But the problem of Canary releasing is routing traffic to the new service that you've just brought up. Not only do you have to tag your logging output so that you can identify what responses are from your new code, but you also have to route correctly through to that service. And it's generally done via either dedicated headers or cookies. In a distributed system, these must be copied on and passed to all subsequent requests around the system in order for you to trace that request through. Now, there is a fantastic tool called Finagle that was released by Twitter, which is a remote RPC framework used by Twitter, Pinterest, Tumblr, PagerDuty, and Linkerd is the new containerized or pro-container packaging for this. So simply, it will allow you to route traffic to the correct instance of your service across a distributed system, a Kubernetes cluster, and it allows you to switch traffic over to run tests. Frankly, the work required in putting something like this together and testing it is obsoleted by the probably many years of production time this software has got. So simply, it allows testing and continuous deployments and is highly recommended. So in terms of testing, we've spoken about routing traffic to these new Canary instances. Once they're good to go, once they have passed the basic tests or quality checks that you've put in place, which are likely a subset of your acceptance tests, the non-destructive version to avoid hammering or clobbering your production data, then you can cut over to your new service and gradually phase the others out. Again, this all sounds pie in the sky, but these platform as a services give you the basic tooling, the primitives with which to do this. And I can't stress enough how revolutionary this is as someone who's been hammering away at this sort of problem for many years. It's solved in a fantastically elegant way. There is always one caveat to continuous deployment, and that is database migrations should be done with extreme care. The addition of a new field rather than the replacing of a current one is absolutely paramount. Putting them in place side by side, slowly writing to the new field, and ensuring that there's no traffic, as it were, to the old field before deprecating it. It's far easier than doing a destructive database change and then having a requirement to roll back because of an emergency a piece of code that you've deployed, and then you're inconsistent between your schema and your application. It's not a situation that it's worth being in. So, and then back finally on testing. Automation solves everything. Now, test is non-deterministic, and while automation does not solve everything, certainly your application and its code should be deterministic. The obvious caveat would be when you introduce pseudo-random numbers at some point, or you just call across to a random number generator. JavaScript by default doesn't have a seed concept for its pseudo-random number generator, but there are libraries that do on NPM. And this gives you, again, determinism with which to test. Manual testing is obsolete. Well, developers should know their domain. They should own this thing. They risk not delivering the correct solution. Works on my machine. Docker almost allows this to be the case. That's a valid excuse, with, again, the exceptions that I've raised. And my part works fine. Well, a DevOps is working across the whole system. By extension, a developer shouldn't be siloed, shouldn't be behind the fence. There should be no boundaries to the system. So, catastrophe survival. What to do when it all goes wrong. Satisfying, isn't it? So we're living post-rollback. We don't fail, we continuously improve. The baseline just slipped very slightly. We should embrace failure. Write a failing test case. Stop the pipeline. Did our alerts fire? Does our logging say there's something wrong? Is our monitoring listing the correct servers as having these problems? If not, why not? Go in and fix it. During an emergency, when there's a short fuse, rolling back to a previous known good version is permissible, if you will, but by rolling backwards, you always run the risk that you've introduced some incompatibility in your data model with the newest version that you failed to account for in your previous. And while changing field names is one thing, it's still, in my experience, easier to roll forward, even at the cost of some system outage temporarily, than going backwards. It's always paramount to write tests for whatever regression you've discovered, because we don't want those coming back in later instances. So, reproduce locally. Pray that you don't have a Heisenbug. Docker, again, should reduce this possibility. The environment, the kernel, we know these places, but generally the environment will be the place with the biggest discrepancy between development and production. The kernel can be relied on to some extent, not to break. Race conditions. We need to attach asynchronous debuggers. strace is no good. Console logs will affect the speed of your program. And there are various good solutions, again, all free. Sysdig, dtrace, and the Berkeley Packet Framework. Sysdig, in terms of container visibility, is quite an incredible tool. Whereas the traditional Linux tools, such as LSOF or TOP, will not give you necessarily the right information or the correct view that you need on the information, Sysdig will allow you to slice and dice your data by container name, by modern container metadata primitives. So, the system's broken. Create a failing test case. Fix it. And we're back to continuous deployments. Remember, these techniques are not for everybody. There may be cases where it's not as important to have some of these features as it is to have a slow and ultimately methodically correct version of your application. In web development, that's very rarely the case. And adoption of some or all of these will make your life easier. So in conclusion, large-scale deployments are now possible for small teams with Docker. There's no barrier to the adoption of these enterprise practices. Kubernetes itself is informed by the inner workings of Google's Borg scheduler. It's a Google product, or project, actually. It's an open source project. And they handle the complexity for you. Guys with experience doing this on geographically distributed clusters have solved a lot of these problems that we would otherwise come up against. Traditional configuration management is dying. Application configuration should be inside the container, and it's more important to provision your hardware and your load balancers in a repeatable way so that you have disaster recovery, you have speed of scale out. Terraform will help you across all the clouds. QA teams are an organizational anti-pattern. Repurpose the expertise of your QA team into test case analysis and requirements. Don't allow fear to slow you down. The long regression testing cycles that many major companies employ can delay releases indefinitely. Everything should be code, not only the code, the pipeline. The tests, deployment, alerting, rollback, everything automated. Introducing humans into the mix will at some point guarantee failure. and be more DevOps. Be a generalist. Knowledge is power. Show you care. Support your production code in production. And all these things allow you to release early and release often. Work 9 to 5, go home, and enjoy your weekend. Any questions?
No question.
No questions.